functional programming and winter lo-fi, holiday mix. I think that's not too loud. So I've kind of set my windows kind of better like this. Let's see how's the encoding overloaded. Yeah, well, this is in HD quality. Oh yeah, let's do 144. Let's try now. So one of the things with okay, now it's a bit better. Okay, so last time we did the cond. Actually, this is so last time we did the cond yesterday, and next REPL. So we did the cond, and it's kind of it's kind of weird. Like all of these things get redefined, and you basically are doing the same thing. Like the identity becomes the combinator, and it doesn't become, but it is a combinator. I think it's just one way how to see them. Dapster, hey, how's your learning been? Hey, it's been really great. I'm finally like content. I'm really happy with it. I tacked on another project. I'm writing a virtual machine in C++ inspired by Zoding's virtual machine. I know, yeah, virtual machine video series. Oh, I know that one. Yeah, I was. It's a long one, and also who there is this guy called. He was doing that in C++. There is this guy called Jonathan Birch. I don't know if you know, on YouTube, and he's doing a lot of C stuff. Jonathan Birch. Jonathan Birch. I don't know. Do you know? Jonathan, what is this guy? Come on. Jonathan Birch. Jonathan Birch. Is it Birch? Birch. My computer dying. Virtual. I think Birch. No, it's not. Jonathan Birch on animal sentience and interspecies welfare comparison. Nice, but not that. This guy, Jonathan Jonas, he's just doing, look at this, so much stuff. Jonas Birch, actually. It might be helpful. This, look at this. Coding a virtual machine from scratch in C. I don't know if you know that. I also wanted to check this, but I'm gonna stick with this for now. I don't know if you want this link, but I'll just gonna. Nope, never heard of it. Oh wow, I'll have to look at this. Yeah. He's doing so much stuff, and he looks like he really starts from scratch, kind of like Zoding. But I love the way Zoding describes the code, when he goes alone, even though sometimes it's hard for me to follow. So I've been really happy with this, and it's been going like this is already 13th or 14th video with Lambda. Well, nothing. I mean, I didn't really put it on the, yeah, you could say I put it on the back, but it's more like trying to explore, and then I see what should I do, not like what should I do next, but like this, I'm finally happy with this after many years, because I was trying, and I think that I was trying to learn Haskell and even category theory. I did that Bartosz Milewski course, and I did it twice, and I still don't know what I saw, And when I was in New York, I would go to these, meetups with, about semi-groups and stuff. It was way too advanced, but I thought I can just sit there and, just indirectly learn it, just because I enjoyed, it's kind of weird. I enjoyed, because I found it interesting. I had no idea what they were saying, but the language was somehow, nice. So I went to this course on semi-groups, and I didn't understand a thing. It was a very long course, and I was just, it was so interesting, but I didn't understand a thing. So I think now, now I went to the bottom. I'm just doing, these, lambdas, and a lot of the things make sense. The way how the things go inside, and how the expressions combine, and how they substitute, or even how I guess semantically speaking, one thing is the same as the next thing, even though it seems like it's defined in a different way. And it's just, I can feel it's really helpful. Like even to understand, Nix code, because Nix code, and I'm doing this now in Nix REPL. So in the Nix REPL, look, the identity would be like this, right? So like this, you see? So in GSCI, I would write like this. And here in the Nix REPL, I just do this. So it's nice that I can, write lambdas in Nix REPL. And then the plan is basically reach to the end of the book and somehow catch up to what you were doing, because I can see already, because I'm going very slow with this, and I already have in my head everything what I've done so far. So the identity, the self-apply, the apply, the select first, the select second, the make pair, and now the cond, and then the true and false. And I can see how they are somehow same in the way, and how they are, different. And so by the end of all this, I guess I will reach, because this is still untyped. So by the end of this, I will reach to the realm of, when I would have to go into types, which is really cool, because I already tried to learn about types. I don't know, because this just makes more sense. This is really to learn how everything, this is like the machine code, actually. This is the machine code. So it's really helpful. I don't know. I really will stick to this. And this is already the 14th video, so I will not stop, So how many projects have you put on the back burner lately? No, but I've tried many things in last, how long? 20 years? I mean, like when you said if I use Emacs, I first saw it 1997. I was 12. I would buy this magazine about PCs, and I had no PC back then, but I would read them. And there was one time the theme was about, Linux. I can still see the cover, and they wrote everything about GNU, about Stallman and Emacs. And I would read about it and then think, oh, they would be so cool, And then I installed it at 2008. Yeah, and then I've used it for, a couple of years. So, so it's like I switched, many times, and I tried this and that. So it's been very long, yeah. So I bought my first PC 2008 when I got a job. It was 2008. So that's been like 15 years. Yeah. I was born in 98, so I wasn't around when there were magazines about computers. So I've just never seen one. They still sell them here. I even bought one. I bought one like last week. I bought one last week after, I never buy them, but I just bought one. And it was nice, back then I had no PC, so when I would read them, it was, the smell and everything, and then you read, and then you would see the screens, like screenshots, and then you would just look at the screenshots and think like the code. It was nice, you know. Or like the games, I would read them. I would read the ones about games, so you would just read them and think of the game. So it was, in some sense, it was nice because, and I would reread about the game many times, and then I would play it in my head, what would happen in the game. But all that I had was just the magazine. It was funny. It was nice though, you know. I remember I was very happy with those, you know, magazines. I had like a whole stack of them, like really, like 2 or 3 stacks of them, really big, really big. Yeah. And then I bought a book on C for dummies. That was 1999 or 8. 1998. No, 1997 I bought that book. But again, I had no place to type stuff, so I would just read them. I've been reading a book I've had for a while which talks about the hidden habits of geniuses, and the author makes a point that the geniuses of their craft had a childlike curiosity about them. So it's a good thing that you're fostering your curiosity about how functional programming works and just logic forming in general. Yeah. Yeah. I guess it's good, you know, because one thing is, it's like if what did I notice? It's fun to do this, but it's like it's not my job. So I wonder what it would be different if this was my job. Like I have some friends who think like, why you don't do this as a job? You could try. And I've been doing this for so long, but always like exploring this and that, like almost like long-term ADHD, ADHD kind of a thing. What did I just say? But well, yeah, and it's nice to do this. Yeah, I don't know now what I wanted to say. I mean, I know what I wanted to say, but I think it will take a long time to say it. So yeah, how functional? But yeah, it's good. It's good. Forming in general, yes. You know what? I have some friends. I have a good friend who is like really genius. You know, he was like, he went to when he was a kid. But when I say he's a genius, I mean that in the term that everyone understands. You know, in the sense that he's known here, and he has a high IQ, and he even when he was a child, he did all math stuff and everything. He went to the Olympics in math and stuff, you know, and he's a nice guy too. And one of the things that he said also, it's just that, you know, even sometimes when I would talk to him and say I'm doing like the basic things, and then he would say, well, that's the best. You know, like all of these things that are somehow so simple, it's like he was saying that's the best, that's the cream, you know. And all that job stuff when you have to do, well, that's not the cream. But he was saying also that it's good to do these things for your brain, you know, because it just helps. And he also does all kinds of math-like things. Math-like things, which sounds really terrible. I'm still sick a bit. It's like we had this long, yeah. And one more guy, that was in New York. I went to this Haskell meetup, and also he was, or actually Lisp meetup. It was a Lisp meetup. Oh yeah, things like dementia. Well, yeah, also, yeah, that's a good point too. It's a good point too. This guy was saying in Lisp meetup, he was so nice. His name was Jay Sulzberger. He's like known, I don't know, in New York or I don't know what. He's he's like, I think you can even see one of his, and he's like, J. Sulzberger. Let's see, a Sulzberger. J. Sulzberger. No. Sulzberger. I think J. Sulzberger. Is it? This guy. What is this guy? The experience. What is this? User autonomy. He's some logician guy. Wait a second. The experience. And he's so. It's like he's from Lord of the Rings. He's talking about math and all that stuff like it's the last thing in the world. Univalent and stuff. I don't know. Like.
Yes, he is attempting to. He has his vision of the foundations of mathematics, and if you read it quickly, it seems to be entirely an equational theory, in the most literal, crude sense. This can't be true, but he introduces at the syntactic level some way of handling this, and I don't understand it. I still don't understand how it can have the effects.
Like, he's amazing, you know. There's a quote in the book that differentiates between talent and genius by saying a person of talent hits a target no one else can hit. A person of genius hits a target no one else can see. Oh yeah, that's nice also. But you know what's nice when I read this now, like a vibe that I get? A person of talent hits a target no one can hit. Well, yeah, that's well said actually. Hits a target no one else can see. That's nice. That's nice. Yeah. But the vibe also I get, it's nice, you know, to think, I don't know, to think like, yeah, what helps in work and the concentration is the idea that you want to be of some kind of, you know, benefit. So like you're doing all of this, or even now when I stream stuff, you know, I like share how I learn. And it's kind of, the idea is just to be in some sense, you know, helpful. And that also helps, you know, with the brain stuff and everything. It kind of helps also when you learn stuff, because then it's not about me, you know, not so much about me, but the idea is to, okay, maybe I'll share, maybe, you know, I cannot hit something, you know, I don't know what someone can hit, or maybe I'm not this kind of functional programmer that can do this or that. But maybe I can explore this space the way I can, and someone may find that, you know, beneficial, or ChatGPT can find that, you know, beneficial. But I'm not wanting any money, just to help people learn and create something. Yeah, and that's actually very helpful when you have that kind of motivation. That's very helpful for your learning too. So it's not like, oh, I'm just doing this for everyone and not for me. In some sense, you're doing it for yourself, you know. Like I learn much better now when I stream a bit here and there than when I was all alone. So it's nice, even though if no one comes to the stream, there is something very, you know, helpful about that. You know, it's nice. It's almost like, you know, you don't yearn for a connection, but you are open for it, you know. So that's, I guess that's nice, you know. Yeah. You wanted to stream sometimes to show people how to make stuff. I'm not wanting any money. Yeah, just to help people learn. But you know, also some of the comments on the channel, some people wrote like, oh, it's great. I don't know, not many, but you know, some people wrote like, it's great that you're showing how you actually struggle with this stuff, you know. It's nice. And also when I was interviewing for the Summer of Nix, that was this year, the interviewer said to me, it's like sometimes I see someone, I've been working on this for so long and I was stuck, but now I found a way, and look, I will share what I did. But he's saying like, I want to see how you were stuck and what happened when you were stuck. It's almost like seeing a movie, you know, and you don't see the part where where we see the main characters, you know, fall down, when they struggle and such, because then at the end, maybe that's what you want to see, how in the movie, how they solve stuff and how they rise up and how they fall. And sometimes we miss that in streams, I mean, at least I'm not, in some of the videos I saw, it's like very, you know, look, this is this, you can do this, you can do that. And it's not some, okay, I'm not trying to critique those kinds of videos. That's also nice to have, you know, like short bits and where you can really get information, you know, quickly. But it's also, it's also good to have videos like this, I think, where you just share whatever is going on. But that's, you know, happening. So yeah, I wonder how long will this be, this kind of Lambda thing. Now it's already like 14th video, so it's too long. You know, my secret idea is that Chat GPT or some LLM will kind of, after a couple of years, will extract all the stuff what I have in the videos and make a course, make a short course. You know, I'll just take all the data that I have in the entire channel and just put everything nicely, and I will have a nice course. So I'm just doing, you know, I'm just giving data, just giving data. Okay, that's my secret plan, and now you know my secret plan, so it's not secret anymore. I get you. The main reason why I'm waiting until I finish some projects is to educate myself correctly before trying to educate other people. But yeah, you make a great point. Part of the learning process is struggling, and I think I still have a fear of failing in front of other people. Yeah. You know, it was hard for me also at first, you know, to find that some sort of kind of like a balance. Because as you say, like the stuff that I'm doing here, some of the things are wrong. And like I saw some of the videos and there were some things that were wrong. But I'm trying to make, not wrong in the sense, well, what's wrong, right? When you learn something, of course you go, well, you need to go a bit left and right? Because when you get to the right point, it will be right because of all the wrong stuff you did before, you know. And also it's not just wrong, and it's just basically it's exploration. Yeah. It takes time. It's fine, you know, because I don't see this as like me trying to educate someone, you know. But okay, well, you could say, yes, I do. Educate someone to, you know, just do something, you know, how to learn something. Maybe the idea would be just to show how you learn something, just to share something. You know, one video I saw that were one stream, I guess. There were more streams like that, where people stream how they study. Have you seen those? There's just like a camera in front, and you don't even see the screen what they're studying. Like they say, I'm studying this or that, and there's a camera, and you just see them basically reading something, you know, working. And I was seeing, and you look at it, and that's it. And then I read the comments. The comments were, thank you so much. Thank you so much. That's so great. I'm like looking, okay, because just seeing someone actually studying helps them study. So people like study with her. That was I don't know the name of her, but she was like, study with me, you know. So she would study, and it's almost like, it's like It's almost like you go to a library and you sit next to someone who is also studying. So you feel a certain kind of connection, but it's not like, hey, you look at me, what I'm doing, let's do this together, I will teach you something. It's more like we are all here for this thing, and it helps them. So they wrote like, this is really so nice. It helps me to, study. Even when I struggle, it helps me seeing you, and then I also study with you something else. So I was like looking, that's so nice. That's so nice, right? It's like, that's so nice. Yeah. It's like I'm there for you in this kind of, minimal sense, but I'm there for you. At the same time, I'm there for myself. You know. And it's nice also when I worked in States, I lived in New York for 5 years, and I taught guitar, and almost all the children wanted to be on YouTube, and a lot of them had channels on YouTube, and they would just share what they were doing. And I thought that actually inspired me. There was this kid who was playing a game, and he didn't share like how he's playing the game. He like found a little hole in a wall. I forgot the name of the game. He found a wall in a hole. he he found a wall in a he found a hole in a wall in the game. And he was curious about that hole. And he made like a stream about that hole. Like, what could be inside of that hole? This hole is interesting. In the entire level, this is the only hole in a wall. And I was like, wow. At first, I was like, why would you stream about a hole in a wall? You have to educate, or you have to, show something. But that was so nice. And it also helps to them to speak and to show. It's like a lot of these things, what we do, I guess when we stream, it's also good for yourself. So I think when you say, what about you? How do you feel? Would you work better if you streamed? But like if you showed how you're learning and documenting how you learn, right? Would that help you learn much better? Or would that help you achieve your goals much better? So if you say, okay, one more thing, like I lived with a roommate, and she was a jazz singer, very good one and known, and she records and stuff. And she did this, I remember, 100 days challenge, where she would sing a song. She would just sit and record herself singing a song, like her song. She would just like improvise a song and the text. Right now, you might say, okay, she can sing, but no, it was more like she would sit and today I was going, and she would just sing about what happened to her that day and trying to express herself. And she would do that every day. And on some days she felt bad, so she would just sing, and she would just say, oh, it's hard for me to sing, I was just like, it was very sincere, and that's hard, like, to strike that also balance, because sometimes you're like, I'm too much reflecting on what's outside of me. I'd like to more reflect what's inside, but at the same time, I want to be in this nice spot where I'm kind of balanced. So it was nice what she did, and she did like for every day. So it's good to have those kinds of, that's nice about thing when you stream. You can set some goals, as you said, like I will do today. Oh yeah, you're right. I will stop. Yeah, but that's actually helpful. Like I'm doing now this, Lambda book, so I'll have to keep on doing the Lambda book. I cannot change. I already felt bad because I left the C thing, the C thing with the Lisp. Okay, I'm changing. I should really focus. Blah blah. And if I didn't stream, I maybe wouldn't be so. Yeah. Okay. You're right. How long have I been talking? Look at this. 30 minutes. Yeah, right. Okay, I'll just go into my cond. So, you know, it's funny. We did the cond. And look at the cond. So, but first, okay, let's define what we did so far. Yeah, we had the make pair. The make pair. I get you. What you planning on doing after this book? You know, I don't know. I don't know, because one idea was to do types. I'm not sure what this book is going to be. Like this book, I'm not sure where this book is going to go. And I can already see I will have some more understanding of the code. So I'm actually not sure. What are you planning on doing? But of course I'm staying with something functional. Yeah. Yeah, one thing I heard, Stephen Deal said that after a while you could make a Lambda interpreter in one language. I could do that, maybe Haskell or like something. Because then after this I will know how it works. And then maybe implementing something what I tried to do in C. But the thing with building a list, because I was not so familiar with how this thing works, I think it will be much better then. But I'm not sure actually. This book, what it's going to do, I don't know where it's going to end. I know he's going to switch sometime to a language. Standard ML, he's going to switch. And Lisp. He's going to switch to that and Lisp. So I'm not sure what's going to happen. It's kind of mysterious, you know. So we had the make pair. Lambda. So the make pair is a function that takes an A, takes a B, takes a function. Cool. I think making something like an interpreter sounds like a really fun project, but I have a bias since I'm an inspiring systems programmer. So those kinds of projects really interest me. But oh yeah, like you have a bias since I'm inspiring. Yeah. Well, I'll see. That's cool. That's nice. Systems programmer. Yeah. One thing, you know, one thing I found, which is a really nice book also, Haskell FPGU, Haskell Clash. Check this out. Retro computing with Clash. You might like this. Wait a second when you hear this. Wait. Check this book. Can you believe this? Like you directly do it on the board with Haskell. This is an FPGA. This is actually what I'm curious about too. And this may a little bit align with what you want to do too. Wait, this is just slow. Are my frames dropping? No. Can you believe how slow is this? Retro Clash. Ah, he fine. Open. Come on. Dark reader, stop. Okay. So this thing, copy. Check this out. Unsafe. Look at it, unsafe. Pong and everything. Look at this. This is a cool thing, right? This is really cool. I don't know, maybe this book too, you know, it would be interesting. I still haven't decided on this, but this book is kind of looks cool. Okay, so ABF and the make pair is a function that takes an A, that takes a B, and then it takes a function that outputs a pair of A and B. But that's, of course, that's not a tuple. It's basically like, as we said, it's like a promise that it will make a pair, but it needs some kind of a function f. It needs something to do with a pair. Use like, I don't have a pair now. If I do make pair hello and nix, if I do this, I just have a look at this. I just have a lambda string. I just have like a function, and it's just saying, okay, yeah, I'm here, but I didn't do a pair. Ah. So make pair hello Nick. So I would first have to select first, takes the first, takes the second, outputs the first, and select second, takes the first, takes the second, outputs the second. So now I have to do make pair hello next. Then we apply that to select first. So we get a hello and make pair hello next and select second. So we get a nix. Now what we did last time was the cond. You know what's funny also? Yeah, actually I want to do it. Sometimes this thing pops at my mind. So yeah, also as you said, like when I stream, like if something pops on my mind what I don't understand or when I want to go through, I just talk about that. So it's like, and in some sense you practice finding that balance, how you study. But okay, I won't. You're right, this channel would turn into... Okay, but wait a second. I was confused because that in the church pairs on the wiki page, they showed the select first in a different kind. It's not the same how he showed it. He showed it in really this form, A, B, A. But it's interesting that the select... What if you want to do this, right? Like first I thought I can do this. But this won't work. Now why? Why this won't work? It won't work because of the substitutions. So if I go to cd, wait, lambda. So if I do select, select first and do make pair, and I do A and B, right? So the select first is what? A, B, A, and let's do it, yeah, let's do A, B, okay, let's do it like this. A, B, A, and then we have a new one. And make pair is what? A, B, F, F, A, B. And then we said, and then we have A, B. I already have A, B. Maybe I'll just put these actually in better names. I put like 1 and 2. Wait, maybe like 1 and 2. Make pair of 1 and 2. Okay, AB and then 1 and 2. Maybe I should put this 2 also in. Yeah, maybe 1 and 2. So right. So now what happens? This has to go inside of A. If this goes inside of A, look at this. Wait a second, can we solve this? Because why is this wrong? Select first, make pair. One more thing that I keep, thinking is call by value and call by need. So most of the languages are called by value. I'm not sure the correct term would be statically, I don't know. Call by value is like it evaluates all the arguments when you apply when you apply a function. And call by need is only, it will evaluate what you need. So you could have, let's say you could have a branch of code that does not compute. But if you don't call it, the program will work, right? And in call by value, it won't work. Even though you don't need that branch, it won't work because it will check it. So you see it checks the whole, it checks everything. So in some sense, call by value is like I have a function name and I show, instead of the function name, I show the definition. So it's almost like I evaluate it and now I apply it. But sometimes I see like sometimes, what's the first thing that I should evaluate here? Do I substitute 1? Because I want to show why is this wrong. I could do 1, look at A, B, F, F, A, B, and that's 1 and 2. Well, I think we could do it like, okay. Okay, actually, okay, let's substitute this entire thing for A. And we remove the head of the A, we're going to be left with B, and instead of the A, we're going to have this again. So all that we're going to have is this. Well, yeah, we're going to have B, and then A, B, F, F, A, B, right? And we're going to have 1 and 2. And now we could do it like this, right? And B, and now we do 1. Now 1 is going to go instead of the A. And B is going to go instead of the B. So we will remove the AB heads, which are the 1 and 2, and substitute them in the body of the definition. So we are just going to have F, this, F, yes, and 1 and 2. Okay, now you see that we're stuck. Yes, I can see now that I'm stuck. We have a B here, we have a F here, and 1 and 2. And now what can we do? The B will select the first. The first of what? It won't work. Look at this. That's why the select first has to be on the second spot. When it's on the second spot, right? Let's say we did this. So we have F, 1 and 2. F1 and 2. And let's go back to our select first, right? And select first is what? Well, look, we already can do it. We even don't have to substitute it for the function definition. We can just take the select first, we plug it in here, we remove the head, and now we have the select first 1 and 2. And the select first is what? A, B, A, right? A, B, A. We can do it like this. A. We even don't have to do it, but okay. A, B, A. 1 and 2. And now 1 will go inside of the A, right? And we remove the A head. So now we are left with B. B1 and 2. B1 and 2. And now 2 will go inside of the B, and oops, there's no B in the body. So that means we just left with 1. That's how we get to select first. So this was wrong. But how would you do the select first? Because almost that's how you would think. Select first from this, right? So the trick is, I saw it in church pairs, is to define the select first. Let's go back to Nick's REPL. So the trick is to define select first like this. Let's do P. Wait a second, P. Is this possible? Could I do like this? X, A, B, A. Look at this, P, A, B, A. You see, we just need one more head here. and an argument in the body so that we can switch them. We need it's funny, it's like it's the select first is going to end up on the right side and it will go inside, right? So like this, can this work? It does work. So now if I do select first hello and next, it won't work, right? It won't work. Attempt to call something which is not a function but a string. You see? But now if we define our make pair as A, B, F, F, A, B, right? So now we have a make pair. Now we can do, and now if we do it like before, make pair, hello, next, select first, it won't work. You see of this P thing. But now we can put select first at the beginning and make pair, and then hello next, and now it will not work. Select, I thought this will work. So make pair. Oh, it's the evaluation. You see evaluation. So make pair is trying, it's not gonna substitute the select. Oh, this is interesting. This is very interesting. Wait, I think ChatGPT will have something to say here. This is very interesting. Now this is very interesting. Okay, what is very interesting? I saw in the wiki page of church pairs that the select first is defined as lambda p dot p and then lambda p dot p a b. Well, let's do it like this. Lambda defined as using the Nix REPL. Let's stick with the Nix REPL. So lambda p dot p and a b a, right? Select first is defined as using the Nix REPL lambda p dot p a b a, and then that means that it can be put in front of the make pair function, lambda function, so that then the make pair that has two arguments can substitute the head lambda p dot p in the select first head, and that basically switches the position of functions. So we do get the proper make pair and then the select first. But when I do this in Nix REPL, I actually talk. No, it's actually nice to talk. I'm now actually typing, but I talk to ChatGPT like this. It's very helpful. Okay, I'll just keep on typing now, but then I will talk. But when I do this in Nix REPL, it doesn't work because it evaluates the arguments in the make pair, which makes me think of the evaluation order. Why doesn't it first substitute the outer function? So this is interesting. That's a fascinating observation, and you're into the key concept in Lambda Calculus. I like this with ChatGPT. He's really like he, I don't know. I have the voice of a her here. And functional programming, evaluation order, and the difference between normal order and applicative order. That's what I was saying, call by need and call by value. In normal order evaluation, the outermost function is applied first, and arguments are substituted without being evaluated until their values are required. Yes, and Nix is a lazy language. So this is how Lambda Calculus operates by default. In contrast, applicative order evaluation, used by most programming languages including Nix, Well, what do you mean? Nix is lazy. Evaluates the arguments of a function before applying the function. Let's break this down. Your select first definition. Select first, this is a higher order function that takes a pair, a function p, and applies it to ABA. Wait a second. Maybe I defined it wrong. The select first takes a function. Wait a second. Church pairs. Yeah, I had no idea about church pairs. Look at this church encoding. Church encoding. Look at this. Church encoding. Plus. Look at this, plus defined only with Lambda Calculus. Successor. So all of these we are going to define, right? So I guess then when I use some kind of a language, it will not be so hard basically to understand what I'm doing. I think the problem with, building Lisp in C was that I didn't really understand how Lisp was built. I mean, yes, like the idea was there, but not like this. This is like really getting to the bottom of it. One more thing is that Lisp is not based on Lambda Calculus, even though it's like lambdas and everything. I heard this recently in a talk by David Turner. He said that John McCarthy himself said that he never read the Lambda papers from Church. He was inspired by Lambda or like something, but at the time when he wrote Lisp, he didn't actually read that, so that's why Lisp was interpreted slightly differently. It has this apply and eval and the quote, and that's kind of something else. That's not really, yeah, it's an interesting talk by David Turner. Where is the church pair? Look at this pair 0. Okay, another way of defining predicates. F, lambda p pair, second p successor. Oh, pair, division, church pair. Where is the church pair? Look at this. The division. Look at this. Look at this. The divide. Wait a second. Plus, minus, transition, church booleans, predicates, church pair. Church pairs are the church encodings of the pair type, two tuple type. The pair is represented as a function that takes a function argument. When given its argument, it will apply the argument to the two components of the pair. The definition in Lambda Calculus is, that's what we have. Pair is lambda x, lambda y, lambda z. Okay, we had a, b, and f. And then f, a, b. So look at the first. So the first is lambda p dot p, lambda x dot lambda y dot x. So the first pair, so you look at this, lambda p dot p, and what does it do? First, you see he writes the first outside because it has this head. So first and lambda x dot lambda y dot x. So, okay, that's the definition of the first. And this is the definition. Wait, I put this more actually. So this is the first here, this here, and this is the pair. And this is the a and b that we want to combine. So let's see what's going on. Lambda p dot p. Oh, the a and b's are already applied, but he's not applying the function. That's interesting. Oh, something is different about Nix. But you know what's weird? Nix is lazy, and this still doesn't work. You know, it's nice Maybe we could check, you know, like on Twitter, why this doesn't work. This is a higher order function that takes a pair and applies it to ABA. Your make pair definition, right. This creates a pair as a function that when applied to another function supplies A and B to F. Application, when you apply select first to make pair AB, select first make pair AB. In Lambda Calculus normal order evaluation, select first body, P ABA substitutes P with make pair AB. That's the normal order evaluation. So the result is make pair AB, ABA. That's what I thought is going to happen. And this expands as ABF, FAB, AB, ABA. And so you see that's the switching part when we have the select first and after the function. And then substituting F with ABA gives ABA, AB, which evaluates to A. Why it doesn't work in NixRepl? Nix uses applicative order evaluation, meaning it evaluates the arguments of a function before applying the function itself. But why? No, that's applicative order. Nix language, applicative order. You see, sometimes I find things like this when I, you know, study. And one time I found something with Nix like this, and that was my first GitHub actually contribution, which was kind of cute, and it's been recorded on the stream, right? I saw I should, you know, report this, and it was just a small thing in the documentation. And then I kind of went along and went to the GitHub and reported it and sent it. I went to the chat even, and I recorded all that, which was kind of nice, you know. It's cute than just, you know, here's my first contribution. And it was not even planned. So that was nice. Nix language basics. It's just funny. Nix language lazily evaluated. If it's lazy evaluate, why does it? Wow, this is something else. Carbon. Maybe we can check that, you know. So what would be right? We can tweet this and check if someone writes something. So this doesn't work. No, what am I doing? Nix, wait a second. SETI auto. Does it have Nix? It doesn't have Nix. It doesn't have Nix. Oh wow. Or maybe I can just screenshot it. Make pair hello. Nix select first. Maybe let's write actually Haskell or something. Auto, okay. NixRepl make pair hello Nix select first does not work. What are we going to do? So make pair is A, B, F, F, A, B. Let's write one more. Hello, Nix, and select first. Did ChatGPT wrote that too also? Select first, make pair. Select first, make pair AB. Oh yes, that was different actually, make pair AB. So it says how to simulate normal order in extrapol. Wait a second. To simulate normal order, you can wrap arguments in lambdas to delay their evaluation. Oh, I didn't know this. Wait a second. To simulate normal order, you can wrap arguments in lambdas to delay their evaluation. A, B, F, F, A, B. Or use a higher order function to wrap your arguments. A, B, F, F, X, A, Y, B. Really? This is strange. I had no idea. This ensures A and B are not evaluated prematurely, allowing the substitution to occur correctly. Will this work? Delayed make pair. Let's try the first make pair. Okay. Make pair. Make pair is what? A, B, F, F, A, B. Really? Like this? Okay, let's try now. Select first make pair. Hello, next. It doesn't work. Okay. Yeah, this probably delayed make pair. Let's X and Y. Interesting. Let's try this. Really? Like this? X and Y? No. Attempt to call something which is not a function. But it's just I'm confused because it's... But they say nix is, and I saw it when I have to use strict to forcefully evaluate the arguments. They say nix is a lazy language. How do you explain that? You're absolutely correct that nix is a lazy language. This means that in generally does not evaluate expressions until their results are actually needed, like normal order evaluation in Lambda Calculus. However, there are nuances how laziness works in practice, and these nuances can explain the behavior you're observing. In nix, expressions are only evaluated when their values are required. For example, if you define a value but never use it, nix won't bother computing it. And 3, yeah. X is never evaluated because its value isn't needed to compute the result 3. Okay, your case. Function application nix, when you write something like select first make pair B, nix does not immediately evaluate make pair B. However, once select first tries to use its argument P, oh, nix will evaluate P. I get it now. To the extent required by select first. This is where the subtleties, I get it now. So the select first engages, Select first takes this, but I thought it will take this without evaluating it. This is where the subtleties arise. Yeah, select first is P, P, A, B, A, expects P to be a function. When you pass make pair AB, nix treat it as a function. However, as soon as select first applies ABA to P, make pair AB, nix evaluates make pair AB in order to apply it. So how do I... Okay, so how do I write first, select first, and then make pair with 2 arguments? To fully align with Lambda Calculus, wrap the application of make pair in another function to prevent premature application. He's doing select first P make pair. Oh, we didn't try this actually. We didn't try this. So make pair is A, B, F, F, A, B. Okay. So then select first. Right, we're gonna do now inside here, P, make pair AB. Will this work? Make pair, oh, it did work, but it's kind of select first. Can I do like P here then? P select. No, it won't work. Interesting. Can I do strict here in the REPL? No, I cannot. Yeah, you see, but this is interesting. There is no way how to do this. How would I do this? How would you do this? How would I do this? Yeah. How would you do this? ABF, hello, Nix, AB, F, FAB. Let's do this. And let's do select first. P, A, B, A. Hello, Nix. How make pair hello, Nix, select first does not work. How would you fix this? I don't know. How would you fix this to evaluate it? To have select first before the make pair. Select first, A, B, A. Select first, also select first, PP, A, B, A. And let's do make pair. Select make pair A, B, F, F, A, B. So the expression is going to be select first, make pair, hello, next. How would you fix this to evaluate it, to have select first before the make pair? Select first, PP, ABA, make pair, AB, F, FAB. This works. So this doesn't work because make pair is calling. This doesn't work. This works. Make pair, hello, next, select first. So then we have F, A, B, F, F, A, B. Hello, next. And this is A, B, A. Okay, we could share this. How would you fix this to evaluate it, to have select first before the make pair? Maybe let's make SETI, wait, Nord? something monokai. Okay. How do I tweet this? Export. Exporting. Carbon. Okay, pictures. I'll go to X. Maybe I have, a couple of people. I have a lot of, actually. I have some good, Nix people here on Twitter also. Except, I didn't even look at this. I didn't even sign in. I've changed to Blue Sky and also Mastodon, but there's still a lot of sign in with Google. Let's do this one. Okay, so now I'm gonna check. It's just the new login. Okay, upgrade. What is this? Post. Pictures. Carbon. So Nix is lazy, but I can't. So Nix, I don't know how to ask this. Any ideas? Maybe about this. Any ideas how to? Any ideas? Nix is lazy, but here in this case, it evaluates the arguments before the substitution. Learning Lambda Calculus. So trying this out in Nix REPL. I don't know, maybe like this, everyone. Post. How is my stream going up? Yeah, encoding overload. Okay. So what do I have? A new would be excellent. Okay. So, okay. So now we have something. Yeah. Okay. Let's see. So it's funny, like this is already a longer stream, but I haven't really done much. But it was nice to like documenting this. Like you cannot plan this. Sometimes you will like be doing this at home and not stream, and you say, oh, this will be a nice, subject. Even though it's not like you create something, but you kind of, you struggle with something and trying to understand it. We can model a conditional expression using a version of the make. Okay. Well, we tried something. Okay. Def cond. So, it's cool that the cond, and Lisp has a cond. The cond is same as make pair. Look at this. The cond, where did we start? The cond is, what's the time? The cond is also like, it says E1. Okay, it can be with A, B, and F, right? It takes a E1, it takes a E2, and then it takes a function. Okay, it's written C. And he put it in, well, we don't really need this CE1 because the evaluation actually happens like this. So the first thing that is applied is C2E1, and then that thing is applied to E2. So we kind of even don't need this. So this is the same as the make pair function. E1, E2, C, E1, E2. It's like A, B, F, F, A, B. But I guess the semantics are now different. Consider cond applied to arbitrary expressions. Okay, we did that last time. It works like make pair. So we just applied two things and we got C, E1, E2. So basically, let's say hello Nix, and some function now is being applied to hello Nix. Yes, you get here, you see this? Now, if this function is applied to select first, this is what we're trying to do now, and the select first will take the first expression, the E1. And it is applied to select second, we will take the select second, right? So notice that the condition is the last argument for cond, not the first. I still didn't understand what this means. No, this is Lambda Calculus. You could do this also in, Python. Yeah, although I'm inside of the Nix REPL, I'm just using it to write Lambda functions. You can do this in Python, I think, with lambdas. You even have lambdas, like lambda, I think, something x return, I don't know, return the x, or I don't know, like that something. I'm not sure. David Beasley did a great talk on this, if you want to check that out. It's a really long talk, like a workshop kind of a thing, where he introduces the Lambda calculus using the Python. So now actually I'm defining cond, right? The conditional that applies something to the first or to the second, which is like this. We have a cond, and then we have the select first. So if I have cond hello, or like let's call it true and false. Not yet in the mode to learn new stuff. Yeah, thanks. Okay, yeah, sure. Cond true false, and then I do select first, and it won't. Oh, because I have. Okay, yeah. Select first. In C++, we refer to lambdas as closures, which are anonymous functions. Yeah, also. Yeah. So select first. Select first is you have one thing, you have the second thing, and you get the first thing, right? So now we have the cond hello, no, true, and false. What this? I kind of miss always this. Select first, and we get a true. Oh, basically we don't have to call it now. Well, no, let's call it true. True, A, B, A. True is something that gives you the first thing of two things, and false is something that gives you second of two things. This is how you define true and false. So now cond, true, and false, and true. So now we're going to get true. And cond, true, and false, we're going to get false. Right? That's it. Anonymous functions. It's funny. It's like, yeah, when you don't call them, you have to recall them each. Yeah, they kind of go away once you use them. Because if you would wanted to call them, you would have to redefine them, right? It's almost like me having A, right? A, and I call that on 2, and I get a 2 back. So this is in kind of, it does not have a name. But if I give it a name, identity AA, now I can call it. Now it's not anymore anonymous. I think that's, maybe this is a too simple example. I'm not sure how is that in C++. Okay, now we will use the conditional expression and con. Define true. Oh, it's nice. Yeah, I redefined it. I redefined the select first, but look at this. I had this. This was actually much better. I had the select first as A, B, and A, and I had the select second as A, B, and B. So more functional would be to, combine things that I already have and create new things. That's the functional approach. You don't want to redefine something that you already have. So we already have the select first, select second. So what we're going to do is true equals select first, and true equals select second. So this is a much better now. Now we reuse the select first and select second to define true. No, what did I do? True is select first, and false is select second. Yeah. Okay, to model some of the logical operators. Okay, that's where we stopped actually last time. Defining not. No, I had no idea. I remember I was watching that course on the Lambda and I had no idea how to define the not, which will describe through a truth table with x standing for this single operand. X, yeah, well, you have a false and not x gives back the true. And you have a true and not x gives back the false. So how would you define not? By using what we know. Like, I don't want to go ahead and see what did he already no, I wouldn't want to watch. Know that if it's operand true and the answer is false and the operand is false, then the answer is true. Right. Thus not could be written using a conditional expression. Oh, now he did it. We can describe this using selectors. So if the operand is true, then... oh, wait a second. We could define not using cond, but instead of giving back the first, he's going to give us back the second. Wait a second, wait a second, wait a second. So let's define not as conditional of true and false if the condition is true and false. It's almost like select first. You see this true and false gives back, oh, give back true. No, give back false. And if it's false, give back true. It's funny, almost like I can define not true. Not true. Look at this. Not true. True. It's false. You see, this is, I think this is like the basic thing in programming. I don't understand. Because not should work for true and false. I cannot just think like this straight. Like I will define true and then not true will give the opposite of not of true. But what do I do when I have false? Not. Cond true. I cannot define not. Yeah, I have no idea now. Not true gives back false. Not false gives back true. Maybe I should do it in more steps. Okay, maybe I'm trying to do this all at once. I could define not. No, I could define like false out of true and true out of false. And then define not. In how many steps do I have to define not? It's funny. This is like, you see, I'm like trying to build Lisp in C And here I cannot define a not. So that's kind of interesting. We can describe this using selectors. So if the operand is true, then false is selected. And if the operand is false, then true is selected. So if the operand, so he's now suggesting here, operands. So the operator is the function, the operands are the arguments to the function. So if the operand is true, so cond true, then false is selected. And if the operand is false, then true is selected. I have no idea. My brain is now. And I shouldn't be stuck like this trying to think. I should do something. That's the thing with when you're stuck. You shouldn't like thinking. You should do something. Not at least anything. At least the wrong thing. Not a conditional. Lambdas. Wait a second, I have a cond. Maybe is it A? Could I use cond already? No, A, B, F, FAB. And select second. Let's do something very silly. FAB. A, B, B. This will just select the second. This makes no sense. Best viewers on elite promotion. Okay. Don't know what that means. Yeah, I don't know. Look at this. Oh, I wouldn't get this. Look at this. We can describe this using selectors. So if the operand is true, then false is selected. If the operand is true, this suggests using... Okay, I'll probably have one more stream just about not. Define not is what? Lambda x. We apply cond false true to an argument which is outside. We substitute that thing. You see, I'm still not actually thinking in the functional way. This is what I see about this, that it takes really time to learn the substitutions, how the thing, really works. We are applying this to something, but we need to have a head. And we need to bind it here in the body. So the true outside, it's going to go inside. We remove the head. The true is going to go here. And then the cond false, true, and true. And it's going to pick the... You see, I have to do this on paper. Simplifying the inner body. Look at this. Let's try this. Yeah, this will take time. I'll have to also practice this on paper. So we have a x. Really, like this? Cond false. Will this work like this in the REPL? True. X. Wow, not true. Lambda string. How do we do? How do we? Yeah, we could. I guess we cannot even. Yeah, we can see it working. Oh. Simplifying the inner body. Let's see. Cond false true x. Lambda E1, lambda C, E1, E2, all right. That's the cond function. And we're going to give it false and true. Right, so it's almost like saying cond and false and true. Right, cond, false, and true. And we are providing it a true. So I was right at first. I said cond true and false, and we give it a true. Basically, that was conceptually, right? That's the idea. Not is something, a conditional of true and false, or I thought select first. But he's saying true. Yeah, I'll need time to actually parse this. Lambda E, lambda E2, lambda C, CE1. So that's the cond or the make pair. Make pair of what? Of false and true. And X outside. So that's the X that we're going to, you know, check. Or that we're going to turn around. So lambda E2. Okay, so the X... What is he doing now? Oh, he's applying false. He's applying false to E1 because E1 is false. Yes, at the end we're just going to get lambda C, C false true. He's substituting the E1 for false, and then we have E2, lambda C, C false E2. Now we're going to substitute true for E2. So we're going to just remove the E1, E2 heads. We're just going to have a lambda C dot C false true X. And now, lambda C, C false true X, right. But what's the X? Now we're going to substitute lambda C dot C with X, right. We're going to get X false true. And now we have the select. So we will use define not lambda X dot X false true. Let's try not true. Not is defined as lambda X, X false true. Not true, true is going inside. Not true, lambda X dot X false true, true. True substitutes for the lambda X head. We remove it to get true, false, true. Now, oh, he's substituting the true and false and true. Wow. Yeah, I will have to do this with pen and paper. Now, he's substituting the true, just the true, not the false and true, just the true. And that's, the true was, if you remember, select first. So ABA. ABA false true. True substitutes the first head. We get lambda second first. No, it substitutes the first. We get lambda second. Wait a second, false is actually the first now. And false substitutes the first. We get lambda second false true. And lambda second false true, we substitute the true and we get the false. Oh, fascinating. Okay, I'll practice this on paper because it will take a while. I'll practice this on paper and then I will practice it here next time. Yeah, I want to do this on paper because it's really hard to do this on the... I have a paper now, I'm doing it also on paper. But interesting, so in not, we are again applying everything what we learned so far. Okay, what's the time? Hour and a half. Okay, that's enough. Okay, so I'm going to leave now with not. I'm not going to leave now. I'm going to leave with a not. So thanks for watching and bye. Have a nice day. Night. Okay, I'm going to check this now with pen and paper actually and do some stuff. All right. Bye-bye.